The stars above me are closing in, so water roll me home.
D2 Inc. Oceanography News.
Day will come, but not as long.
Our first story comes out of the Scripps Institution of Oceanography, and it's in regards to the LA wildfires. While conducting a marine ecosystem survey near Los Angeles as part of a @Cal Coffee expedition, researchers with Scripps Oceanography and NOAA Fisheries West Coast Southwest Fisheries Science Center encountered an unexpected variable: falling ash from nearby fires. The crew quickly adapted the survey crews, taking the opportunity to sample ash from sources ranging from household chemicals to building materials, while also assessing any effects on the marine ecosystem. These fires are not only consuming vegetation, but also massive amounts of urban infrastructure, said project leader Julie Denisquet of Scripps Oceanography. This introduces a novel urban ash component to the wildfire source, filled with exceptionally toxic materials such as heavy metals like lead, arsenic, as well as asbestos fibers, polycyclic aromatic hydrocarbons, and microplastics. These fires pose a potential significant threat to both humans and ecosystems through the introduction of a large amount of toxic material in the system. You can learn more about the complex interactions between wildfires, atmospheric particles, and ocean ecosystems by heading to the link in the description box for this YouTube video to the original source article. Keeling curve. New record for annual increase in Keeling curve readings. In 2024, the yearly average level of greenhouse gas carbon dioxide rose faster over the prior year than ever before in the 67-year-old Keeling curve record. When researchers took the average readings for all 12 months in 2024, the average was 3.58 parts per million, higher than the 2023's average. That broke the record for the largest jump set in 2016 of 3.41 parts per million. Ralph Keeling, who leads CO2 measurements at UC San Diego's Scripps Institution of Oceanography, said that in both instances, the climate pattern El Niño played a role. This record growth had certainly got a boost from the 2023-24 El Niño event, which also helped explain the record growth that we reported last May, said Keeling. Although this El Niño event ended early in 2024, it is often the case that El Niño events are associated with higher than normal CO2 growth extending into the northern hemisphere summer following the El Niño event. This last year fit that pattern, but the CO2 growth might have been further boosted by wildfires in North and South America, Keeling added. The ultimate cause of CO2 rise is the burning of fossil fuels, but the rise rate also fluctuates from year to year due to CO2 exchanges with the ocean-land ecosystems, including from fires. CO2 levels are not just at the highest level in millions of years, they are also rising at a record pace. The latest results further confirm that we are moving into uncharted territory faster than ever as the rise continues to accelerate, said Keeling. This analysis coincides with a new report from Keeling and UK's Met Office, which issues forecasts of the annual CO2 rise. Met Office researchers noted that the rise is now incompatible with scenarios used by the Intergovernmental Panel on Climate Change to assess limiting long-term average global warming to 1.5 degrees C above pre-industrial times. Quote, limiting global warming to 1.5 degrees C would require the CO2 rise to be slowing, but in reality the opposite is happening, unquote, said Richard Betts, who leads the Met Office CO2 forecast team. Quote, even without the boost from El Niño last year, the CO2 rise driven by fossil fuel burning and deforestation would now be outpacing the IPCC's 1.5 degree scenarios, unquote. Deep sea's dark oxygen is the most profound discovery of our time. Deep sea scientists have praised the discovery in the last year of a second source of oxygen, known colloquially as dark oxygen, for being produced in complete darkness on the deep ocean floor, for being one of the most profound discoveries ever made by the Scottish Association for Marine Science, and transformational for our understanding of life on Earth and elsewhere. The discovery caught the attention of the scientific community around the world when it was first detailed in 2024, including those at NASA who believed dark oxygen could be key to understanding how life could be sustained on other planets and in habitats previously assumed to be incompatible with hosting life. What could potentially be a groundbreaking revelation for modern science, the emergence of dark oxygen has since received the public backing of institutes around the world, including IOC UNESCO, which has now endorsed the project as UN Ocean Decade Activity, and the world's largest philanthropic organization, the Nippon Foundation, which is funding new and extended research into deep-sea dark oxygen via a £2 million funding package. The project will be the most detailed examination yet of our deep ocean, which could provide clues to how life on Earth began, said Professor Nick Owens, director of the Scottish Association for Marine Sciences. I've said on a number of occasions, and I truly believe, that this is one of the most profound discoveries ever made by SAMS. Kicking off a multi-year research project, the team led by Professor Andrew Sweetman, leader of seafloor ecology and biochemistry research group at SAMS, will send purpose-built sensors to the deepest part of the ocean to further probe the discovery they made last summer of dark oxygen. Made possible by the £2 million funding from the Nippon Foundation, the team anticipate that the first sensor will most likely be ready to go within 3 years from now, making this a crucial time frame with the Ocean Action Decade. Findings from the research could provide critical to the adoption of the ocean protection measures made by nations around the globe, now staring down the 2030 deadline.
We have found that there is oxygen being produced in complete darkness at the bottom of the Pacific Ocean. Now, this is really, really exciting because up to now we've thought of the deep ocean as being an oxygen sink, and all of the oxygen that's available in the deep ocean comes about from photosynthesis in the upper ocean and on land. And then that oxygen diffuses into this ocean and sinks down into the deep ocean where it provides an oxygenated habitat. What we're showing now is that the deep sea is able to produce its own oxygen. We went out to the Pacific Ocean with an instrument to measure the consumption of oxygen at the seafloor. Now, normally what happens is as animals and microbes move around in the sediments consuming organic material, they consume oxygen. So if you enclose a known area of seafloor, you can see the oxygen slowly go down over time. And what we've found is that the oxygen is actually increasing. And when the instrument came up from the seafloor and we downloaded the data from the sensors, again, the oxygen was increasing at the seafloor, which up to then I thought was impossible. So suddenly I realized that for the last 8 or 9 years I'd been ignoring this oxygen production mechanism. Subsequently, in the last 2 to 3 years, we've been trying to explore the mechanism for this oxygen production.
The fact that we've got this source of oxygen produced by these manganese nodules. This is one from the bottom of the Pacific Ocean where Andrew Sweetman's been working, is really exciting and staggering.
That what was happening was the same thing that happens when you drop a battery into seawater. It starts fizzing because the electric current that's generated was splitting water into oxygen and hydrogen. So this discovery of oxygen production at the seafloor in areas where you have these polymetallic nodules is really important because to power the green economy, we need to extract metals from the ground or potentially the deep ocean. So what we have discovered means that we're going to have to carefully think about if deep ocean mining goes ahead, where that mining should take place, because this oxygen is likely being used in whatever quantity that it's produced by the ecosystem.
Mining companies, however, are planning to logged their first applications for licenses to begin harvesting this year. It makes the next few years of research crucial for the conservation and protection of the deep seabed. The 3-year research program will investigate whether hydrogen is released during the creation of dark oxygen, and whether it is used as an energy source for the unusually large community of microbes in parts of the deep ocean, as well as how climate change might impact biological activity in the deep sea. This is why research is now crucial, said Professor Sweetman. If the process of dark oxygen is happening naturally, and we extract those nodules, that might have some sort of effect on the deep seabed. The prudent thing to do is go out and explore, try to understand what is going on here before we move forward with exploitation. We know deep-sea mining will have an effect on biodiversity and the ecosystem in general. There are going to be effects in the water columns and at the seafloor. What we have shown is that there may be another effect which we haven't thought about. All we're asking for is a little more time to go out and find out what's going on. We'll try to get the answers as fast as possible, but I think the right decision is to hold off on just a little bit longer before we decide if this is work we need to do as a global society. The project will also allow researchers to study the deep seafloor into the Hadal Zone, an area which reaches 6,000 to 11,000 meters depth and makes up around 45% of the entire ocean. Thanks to the support package from the Nippon Foundation, the team will develop purpose-built and autonomous landers, carrying specialist instrumentation to those depths. These will be the first UK-based assets with the capability of sampling below 6,000 meters. Yohei Sasakawa, chairman of the Nippon Foundation, said, "The sea is vital to sustaining human life and biodiversity, but even today so much of the deep sea is unknown. We are passionate about innovating to achieve a better society, and we are proud to support Professor Sweetman's research into dark oxygen, in the hope that we might learn more about the deep sea and the life which exists at the bottom of the ocean." IOC UNESCO has already endorsed the project as a UN Ocean Decade activity, while Professor Nick Owens, director of SAMS, has celebrated how fitting the project is to be undertaken this year, the 150th anniversary of the discovery of the deep ocean. As an institution, we trace our roots back to the UK Challenger's expedition of 1872-76. He said, "It is fitting that 150 years after that expedition gave us our first insights into the deep ocean, we are now uncovering some of its best-kept secrets." Dark oxygen can be produced in complete darkness on the deep ocean floor where light cannot penetrate. Its discovery challenges the previously held scientific consensus that oxygen is produced solely from light through photosynthesis. The discovery of the second source of oxygen is therefore called into question how life began on Earth. It was also the discovery that never happened, with the correlating data largely ignored by Professor Sweetman and the team behind it for the best part of a decade, perceived at the time as an anomaly. However, upon returning to the data some 9 years later, the SAM scientist was finally convinced the data was pointing towards this groundbreaking truth. Our discovery of dark oxygen was a paradigm shift in our understanding of the deep sea and potentially life on Earth, but it threw up more questions than answers, said Professor Sweetman. This new research will enable us to probe some of these scientific questions. If we show that oxygen production is possible in the absence of photosynthesis, it changes the way we look at the possibility of life on other planets too. Indeed, we are already in conversation with experts at NASA who believe dark oxygen could reshape our understanding of how life might be sustained on other planets without direct sunlight. Discovery of dark oxygen was made in a region of the deep sea known as the Clarion-Clipperton Zone, a huge flat area of the seafloor that stretches between Hawaii and Mexico. It's an area where mining companies like the Metals Company already have plans to start harvesting the same nodules discovered to be producing this dark oxygen for their rare metals. The research team at SAMS is also seeking to understand if dark oxygen production takes place in other deep sea areas. We'll take various measurements and readings to help identify the source. These investigations will begin later this year. It's uncertain for now just what role these oxygen-producing rocks play within the deep seabed environment and what impact harvesting them via deep sea mining would have on the ecosystem. Given the fragility of the deep sea ecosystem as it stands, however, campaigners have been vocal in putting an end to deep sea mining before it gets started. Next up, we have what is believed to be the largest great white shark ever recorded. This video comes from Oceanography on Twitter. This is recorded near the island of Oahu, Hawaii. Next up, we have a story from Igor Shkavorits from salinometry.com. Today is CTD Appreciation Day, a day to honor the workhorse of modern oceanography. For over 60 years, CTD systems have been essential tools for scientists and ocean researchers, measuring and deriving not only the thermodynamic parameters of seawater, temperature, practical salinity, density, but also a range of other biogeochemical variables critical to understanding our oceans. In my stamp collection, I hold a particularly remarkable piece of oceanographic history, a stamp issued in 1991 by the British Antarctic Territory, displayed by the NVIS Mark III, one of the most iconic CTD systems developed by Neil Brown. It's the only stamp in the world showing a CTD measuring system, and it serves as a small yet meaningful tribute to this revolutionary technology. To learn more about the NVIS CTD and its pivotal role in advancing oceanography, check out his blog, which I linked in the description box of this video. Alan Fougere replied, president of D2 Incorporated, stating, "Neil Brown was my mentor and friend. He was capable of analyzing a technical problem and developing new ways to address it. At D2 Incorporated, we've introduced the next generation of CTD, the hybrid CTD. Our expectation is that this new CTD carries forward an important task of advancing oceanography for the next 60 years. Due to my history or working with Neil Brown, I would be amiss to say Neil's spirit is not present in each one we build." Alan Fougere. And you can check out our website at www.d-2.com. How can delicate glass balls help us understand earthquakes? At Hui, it's all about cutting-edge tech and a little creativity. Encased in glass and protected with orange or yellow hard-hat shells, these ocean bottom seismometers, OBS, collect data on tremors that would otherwise go unrecorded, enabling scientists to study tectonic plates and movements on the ocean floor. Powered by lithium battery packs, these devices can sit on the ocean floor for up to 15 months. Here you can see the glass ball broadband OBS. These instruments are equipped with nanometrics, trillium compact broadband seismometers, and used for year-long monitoring of teleseismic and regional earthquakes. Have you ever wondered how Antarctica got its name? Antarctica's name has ancient roots influenced by Greek and Latin. It means opposite the Arctic, derived from the Greek word Antarcticos, where anti means opposite and Arcticos refers to the northern bear constellations, Ursa Major and Ursa Minor. Essentially, Antarctica is the land opposite the bear. The idea of a vast southern land, Terra Australis, Latin for southern land, existed for centuries. In 1820, the Antarctic mainland was first sighted by European explorers, but it wasn't until the 1890s that Scottish mapmaker John George Bartholomew officially named the continent Antarctica, a poetic nod to its position opposite the Arctic on the globe. So while Antarctica's name describes its location, it also hints at a deeper story, one tied to ancient myths, constellations, and centuries of exploration. And fittingly, in this land opposite the bear, there are no bears, just ice, penguins, and endless wonder. Travel with us. This time-lapse video captures the breathtaking beauty observed during the Antarctic Climate Connections expedition as the team explores in the perpetual daylight of an Antarctic summer. The RV Falkor 2 crew and visiting science party are studying climate connections at the sea-ice interface. Doctors Patricia Esquet from the University of Aveiro, Portugal, and Alexander Montelli from the University College London, United Kingdom, are leading this expedition, which is creating the first high-resolution maps of this remote and understudied region and documenting the animals that dwell there. The science team is examining seafloor creatures carved by glaciers over time and studying the intricate ecosystems living at the interface between ice and sea. Using these high-resolution maps, along with ROV Sebastian, they will advance research on the past ice sheet dynamics, its impact on Earth's climate, and Antarctica's biodiversity. This research will provide critical insights into the stability of Antarctic ice sheet, affiliated deep-sea ecosystems, and how these systems will be impacted by climate change. This comes from Jade Farugia on LinkedIn. Inspired by learning from John Nelson, I recently created a moving map of ocean currents along the east coast of NSW from Brisbane to Sydney. Using a vibrant pink, orange, yellow, and red flow lines, the map beautifully captures the dynamic movement of the ocean. The data was sourced from the HICOM Consortium, which provides high-resolution oceanographic data critical for understanding these incredible systems. Woods Oceanographic Institution had a post regarding ocean currents as well. Ocean currents transport much of the heat, nutrients, carbon, and oxygen that support life on Earth. They also regulate both regional weather and our planet's temperature. So how do we study this vast and invisible vascular system? They released images with this post showing you what life is like on board the RV Atlantis while they're out there studying ocean currents and the various instrumentation that they use to study these currents. The captain of the RV Atlantis has discussed that one of the biggest issues they face can be weather, and that has canceled some trips. They use equipment such as these profilers, and they use equipment on those profilers such as the CTD, and D2 Inc. is now working with Woods Oceanographic Institution to get some of our CTDs onto these types of profilers in the very near future. They also use equipment such as these gliders, which is something that we could also put our D2 Inc. CTDs on for more accurate measurements in a flow-through closed field system. You can see from this chart, Arteries of the Ocean from Woods Hole, how interconnected these ocean currents are, and also how important they are to the regulation of the largest part of our Earth, which is the ocean. Thank you very much for watching episode 5 of D2 Oceanography and Marine Science News, #OceanNews. If you enjoyed this video, make sure to go over to d-2.com, hit the news tab, and bookmark our news page so you never miss an episode. And definitely hit subscribe and like on this YouTube video. Thanks again for watching. Have a pleasant day.